Okay, so we are ending the unit with a really easy and straightforward lesson. This is 6.14, Remainder Theorem. Okay, and this is basically a shortcut for polynomial division, which was the last, the last lesson that you just did. So if we just care about the remainder, so again, we don't care about like the answer, we just care about the remainder, we can use the remainder theorem. Okay, and it's pretty simple how you do this. So we're going to do this question together. It says, if f of x equals this whole thing, then what is the remainder when f of x is divided by x minus 9? So again, you could totally set up your polynomial division question, but again, those are kind of a lot of work and not fun. And it's just asking for the remainder. We don't really care about the rest of the problem. So this is what you do for the remainder theorem. You take the binomial, which is x minus 9, and you set it equal to 0. You always set it equal to 0. You are then going to solve for x. So in this case, x is going to equal 9. You are now going to plug in 9 into f of x. So we're going to plug it into this. So we're going to find f of 9, which means we're just going to plug in 9 anytime we see an x, right? So if I were to put this in my calculator, I need to pull up a calculator. Okay, so if I were to put this in my calculator, you can also do it too. You are going to get 122. So what this means is, like, if you were to do the whole polynomial division and everything, at the end, you would see a remainder of 122. So this actually tells you something, right? Because if something is a factor, the remainder is always going to be 0. So since the remainder is 122, not 0, we know that x minus 9 is not a factor of f of x, right? Because again, the remainder was not 0. Therefore, it is not a factor. Okay, so that's just remainder theorem. It's pretty straightforward. It's pretty easy. But I'm going to show you now how we can use the remainder theorem to actually solve for different things. Okay, so let's look at this question here. It says, given f of x equals this thing right here, and notice we have a k, and the remainder when f of x is divided by x minus 2 is 21, then what is the value of k? So in this case, now they're giving us the remainder, and we're trying to solve for k. So think about the remainder theorem, right? Our first step is we're going to take the binomial, which is x minus 2, and set it equal to 0. We're then going to add 2 on both sides, and we're going to get x equals 2. Now at this point, you usually plug into f of x, right? And we know that whatever answer we get is the remainder. So let me do this. So we're going to plug in 2 in for x. So we have 2 to the power of 3 minus 6 parentheses 2. I don't know what k is, but remember, this always equals the remainder. What you get when you put in your calculator is the remainder. And in this case, we actually know the remainder. The remainder is 21. So I can just say this is equal to 21. So now I have an equation and I can solve for k. I'm going to simplify all of this first. So if I put this in the calculator, 2 times 2 to the power of 3 minus 6 parentheses 2, you can literally type it in like that. You're going to get 4. So I have 4 plus k equals 21. And if I subtract 4 on both sides, I am going to get 17. So the value of k in this case is 17. Okay, let's do one more question. Again, we're given another function where we have a k. We're given the binomial, which is x plus 2, and it's saying, and x plus 2 is a factor of f of x. So what do we know about factors? We know the remainder has to be 0, right? So it's really just the same process. At this point, you should pause and try this question. So x plus 2 equals 0. So x is going to equal -2. I'm going to plug it back into here. So I have 3 parentheses -2 to the power of 3 minus 8 parentheses -2 plus k equals 0. Okay, so if I put the left side into my calculator, I'm going to get -8 plus k equals 0, and so k is going to equal 8, right? And again, we knew that this was a 0 because they told us x plus 2 is a factor. If something is a factor, that means the remainder is 0, okay? So nice, easy lesson to end this unit on. Go ahead, move to the practice. Let us know if you have questions.